So LeetCode 173 binary search tree iterator. For this problem, you need to implement a class that can iterate through all of the values in a binary search tree in order. So starting from the smallest one, going up to the biggest one. And we're also going to solve the Followup, which states that we need to implement next and has next methods in O of H memory and O of 1 time as well. Okay, so to solve this, we can actually employ a technique that you can use anytime that you see this kind of problem where you need to build an iterator. And that's, think of the problem like, how would you solve this problem if instead of having these methods, it just asked you to give back, to return in some way, all of the values in the binary search tree in order? How would you do that? Well, you would probably just have an empty array at the start, and then you would do a recursive in order traversal, and then push the values, right, into that array. Probably that's what you would do. So because you are only pushing at the end of the array, you can basically directly convert that solution where you just push all of the values recursively into an array of all of the values. You can convert that directly to a generator solution. So anytime you would use push, instead just use yield, right? And that will give you a generator on top of which you can build this iterator as specified, right? So yeah, we're going to do that. So how would you do an in-order traversal, and where would you push the values? You would do that like, you would do something like, you'd have your base case. So if you have no node, you return, and then you'd have your recursion on the left subtree and your recursion on the right subtree. And between those two, in the middle of those two calls, you have your something like array.push, and then you push your current node's value, right? So that's how you would push all of the values in the binary search tree to an array. So the only change that we need to do is, instead of doing array.push, we need to use yield, right? So here's the syntax for a generator function in JavaScript. So if you don't know about this, just go read the documentation about the JavaScript generator functions. And here, it's literally the same thing as the normal in-order traversal of a binary tree. So if we have no root, no node, return, right? That's the base case that stops the recursion. And then you yield from a new binary search tree generator built on the left subtree. And then you yield your current value, which is what I was telling you. Like, here is where you would have something like array.push root.value. But instead of pushing it to an array, you just yield it to the caller of the generator function, right? And then you do the same, but on the root right subtree. Okay, so you can see this is literally the same as a normal in-order traversal, recursive in-order traversal. It's just that instead of using array.push, we use yield. And you also need to do yield from this generator and yield from this other generator. So the logic here is, whenever you are on a node, before yielding the current node's value, you want to yield all of the values that are to your left, because we are in a binary search tree, and so all of the values to my left are going to be smaller than me. And only after yielding my current node's value, I want to then yield all of the values to my right. Okay, so yeah, that's why you recurse this way. And now, I mean, all that's left, like, really, we've already solved the problem here. It's just that we need to implement it exactly as in the problem description. So we need some driver code. So at the beginning, we just add an iterator to our class. So this iterator is a new binary search tree generator on the root node. And then you need to do some trickery. So you need to store a node. Like, you cannot, JavaScript doesn't support the hasNext node. So instead, what you need to do is you need to store the result of calling next on your iterator, and then checking if that stored node tells you something like, okay, I'm done, I'm finished, right? So what you do is you check the done property. And again, if you don't know how this works, check out the MDN documentation. But anyways, yeah, this is just a trickery to make the problem work. So the basic idea is here. And so yeah, you, instead of having some method like bstgenerator.hasNext, you need to store the result of the next call. And then if that has a done value of true, then it means that you do not have a next. So we return the negation of the done property of the iteration result, right? And the reason for which we store a node is because, imagine if they call hasNext like 10 times, you don't want to move forward in the iterator, right? So you want to store it and use it for the next time again, right? And then the next method is the one that actually moves forward the iterator. So hasNext here moves forward the iterator only if there's no stored value. But next needs to move forward the iteration every time. Okay, so you can see that we're moving forward the stored information no matter what. Like even if we had a stored value, we move it forward. Instead here, we only move forward if we have no stored result. And yeah, that's it. You just return the value. So for the hasNext, you return the negation of the done property of the iteration result. And then for the next method, you need to return the value instead of the done property. Okay? So yeah, that's it. I'll submit it to show you that it works. And the time complexity here is O of n, where n is the amount of nodes in the tree. And the space complexity is O of h, where h is the height of the tree. So that's it for me today. Thank you for watching, and bye.